Hello and welcome back to Cracking the Cryptic and another puzzle by Randy Dan, and I think it is a fairly similar rule set to the last one, which involved German whispers and these bizarre modular cages and caused me to do quite a bit of head scratching. This one's called Modular Mayhem, so I'm expecting further mayhem. There are some Renban lines this time. I don't know. I don't remember enough about how I went about the last puzzle to know how it should inform how I go about this one. But we will find out all about that in a moment. I do want to tell you about the forthcoming 1st of February Patreon reward, which is going to be Duality 3, a further look into lines that have dual purposes, and that has been prepared by Skunkworks. It's a long pack. It's fantastic. There's a lot of really good puzzles in it by some of the greatest constructors. So that'll be coming out on our Patreon on the 1st of February, 4 p.m. our time. So do check that out. You'll have 20 days for it to be a competition, one winner of which will be elected to, or chosen at random to potentially take part in a collaboration with Simon. That's the reward. And there's loads of other stuff on Patreon, like gridogram videos, connections videos, cryptic crosswords. There'll be a new one of those coming soon. All sorts of things, actually. And solution videos to the prior months. If you're a $3 a month patron, less than a cup of coffee these days, check it out anyway. It is good fun. And if you're not doing that, you might be doing our apps. And they feature line Sudoku and killer Sudoku, but also classic Sudoku too, with the puzzles of Sam Cappleman-Lynes and Nikoli, and oh my goodness, and of course the Worms, which will soon have additions. So fantastic stuff all going on around the channel. But Modular Mayhem is this puzzle, and here come the rules. So normal Sudoku rules apply. At least 1 to 9 will go in every row, column, and 3x3 box. Adjacent digits on a green line have a difference of at least 5, and digits on a purple line form a non-repeating set of consecutive digits in any order. So this could be the numbers 2, 3, 4 and 5 in some order, for instance. Now, these modular cages, digits in a cage sum to a multiple of the small clue given in the cage. So these 3 digits add up to a multiple of 5. Digits may repeat in a modular cage if allowed by other rules. I think this is the cage to which that rule applies, because it's the only one that goes between 2 boxes, I think. Now, has Randy Dan put that rule in because this is a repeat digit? Or is he actually foxing us and it's not? I don't know. We'll find out. I won't be allowed to assume that. It'll be an interesting speculation. You could jump to the end of the video and see if that digit is the same as that, and that's why the rule is there. I don't know. Anyway, those are the rules. I am going to warn you that I've got an alarm set for 20 odd minutes time, 23 minutes time, and I'm going to have to take a break then, assuming I'm still going, which I think I will be. So that is just a warning in advance. Right, you can try it on that first link. Let's get cracking. So, where on earth do we start? I mean, we could mark up the German whisper lines, which must alternate between digits higher than 5 and digits lower than 5, can never have 5 on. Certain positions, although this barely applies in this puzzle, can't contain 4 or 6. I would say those are the only green. Oh no, that one as well. That's not helpful. That's not the place to start. I don't remember anything about these modular cages. I mean, in box 5, we've got a cage that's divisible by 3 and one that's divisible by 4, and then these 3 lines which are on a Renban. Now, we do know a secret about every row, column and box. That's that they all add up to 45. Do just be careful who you share that powerful secret with. Now, since that's divisible by 3, if we take out those cells that are divisible by 3, the rest of them in this box are divisible by 3. Now, if that was a 3-cell Renban line, they would be divisible by 3. And then this would have to be divisible by 12. But it's not a 3-cell Renban line, it's a 4-cell Renban line. Okay, there is a thing with a line of this shape that says that these 3 digits can't be on this line anywhere because all of them see. I think that might be more relevant here actually. Let's look at this line. Let's just colour it yellow for a second. These digits, which I will colour pink for a moment, have to be different because they see all of these yellows. Let's think about these 2 lines. So let's change it. Let's make that light blue. Light blue and yellow. Now, what digits do they contain? And just thinking in terms of the sequence of digits from 1 to 9. Right, where does this digit go in the column? It can't go on its own line again because they're non-repeating. It can't go in its own box again by Sudoku rules. So it must go on this blue line. But none of the other digits in this column are the same because they're all in the same column and Sudoku rules don't allow that. Therefore, that digit is on this line. But none of the other digits, it's clearly on both lines, and therefore it's an overlap digit between the 2 lines. And the yellow and blue digits in this column are a sequence of 7 Sudoku digits in a row. These 3, then that 1, and that appears somewhere here, and the other 3 after that. And that means that these 2 are from 1, 2, 8 or 9. Any sequence of 7 must include all the digits 3, 4, 5, 6, 7. It's either 1 to 7, 2 to 8 or 3 to 9. And these lie outside the sequence that's being used in this row. Now, what can this digit be? It's the overlap digit. It's either 4, 5 or 6. Because this is either a sequence of 1 to 4 overlapping with 4 to 7, or it's 2 to 5 overlapping with 5 to 8, or 3 to 6 overlapping with 6 to 9, or the other way round. And the overlap digit is always 4, 5 or 6. Right, this is a cage that cannot be divisible by 5. I'm going to say... No, sorry, I'm quite wrong. This is a cage that is divisible by 5. I thought this digit was going to have to be 4, 5 or 6 as well. Actually, 5 is nonsense. 5 can never go in a cage that's divisible by 5. These cages divisible by 5 can add up to 5, 10 or 15. And in 2 cells, 5 can never be in those pairs. 10 doesn't work because 5 plus 5 would need 2 5s, and that would always break Sudoku rules. So maybe, could the puzzle be about where 5s can't go? Right, let's get rid of this colouring and start colouring the grid with places 5s can't go. I'm going to do it in green. Right, those cages with 2 cells that add up to a multiple of 5. 5 can't go in them. Now, 5 also can never go on a green line. This is why I'm thinking of doing this. And therefore 5 is getting quite limited where it can go. Yeah, think about, look at all this stuff. Right, I'm going to colour those pink. Now, there is a 5 in each of those 4 boxes, boxes 1, 3, 4 and 6. Where do those 5s go? Well, one of them can go in column 1, one of them can go in column 9, one of them can go in row 2, and one of them can go in row 5. And you can't put 2 of them in any of those areas. And therefore, these overlap cells cannot contain 5 either. Now, I've also pencil marked that digit, which can't contain 5, so that's worth knowing. And now 5 is getting quite restricted. So one of those is a 5 in this row, because there must be one in row 2. That's one of the 4 places we specified. Same in row 5. So now we've ruled out 5 from even more cells. These are ruled out because we need 1 in column 1, and oh look, we need 1 in column 9, and this, no, both of these lines are 5-less. And that's really important on a Renban line. If it doesn't have a 5, it must be either 6, 7, 8, 9 or 4, 3, 2, 1. That digit is 6 or 4, and this group of cells is therefore either 1, 2, 3 or 7, 8, 9. And that pair is determined by whichever this is. So 1, 2, 8 and 9 must be used in this group of cells, and this has to be selected from 3, 4, 5, 6, 7. Now we know one of these is a 5, obviously. Well, we now know one of them's a 4 and one of them's a 6. Down here, we're selecting from, ooh, what happened there? Something. Anyway, we're selecting from 1, 2, 8, 9, 3, and 7. Now, what about this cage? Oh no, this Renban can't have a 5 on it. Is it the same as this one? Do we know? I have rather obscured, by using this green colour to say where 5 can't be, I've obscured the green lines. So let's go with a blue colour to say where 5 can't be. Now, this is either 1, 2, 3, 4 or 6, 7, 8, 9 as well, because all its cells are non-5s. They all see that one, don't they? Right. This one, I'm going to now colour these a different colour. So we will go with red. I don't know whether red is high or low, but I do know those cells are the opposite, so they're yellow. Now this cell is yellow, and it sees all of these cells, so it can't appear on that line. So if it's a 1, this would have to be 9, 8, 7, 6. If it's a 2, the same thing. If it's 8 or 9, this would have to be 1, 2, 3, 4. So this is all red as well, because it can't be yellow. So this, this digit is not now 4 or 6, because it would be the same 4 or 6 as red 4 or 6 there. Therefore, this cage does not add up to 10. Therefore, this digit is either 9 or 1. And I was going to say that means this can't be a 1-9 pair, but we'd learnt that already because these were always going to be yellow. But that is extreme. So this group is either 2, 3, 4 or 6, 7, 8. And that's going to push which... Oh no, it's not going to push a yellow digit because they're a red set. But they're divisible by 3 now. That was something we were looking at earlier. If those are divisible by 3, those are divisible by 3. And that's all true. So now these are divisible by 3 because the central box is 45. And that's divisible by 3. If that group's divisible by 3 and that one is, this one must be as well. If this set of cells in this cage is divisible by 3, we also know they're divisible by 4, and therefore they're divisible by 12. And therefore they add up to either 12 or 24. Now, is 24 possible? This would have to be 9, 8, 7. Red would be 1, 4. 9, 8, 7, 1, 4. This digit would be 2. And over here we would have 3, 5, 6. Can we use 2 of those to make a cage that is divisible by 5? No, we can't. The totals available are 8, 9 or 11. So this is not 9, 8, 7. That's not going to help that much, except now we know that this cage is divisible by 12. It adds up to 12. Not it's divisible by 12. It is 12. If this is a set of 2, 3, 4, which add up to 9, then that is 9, 8, 7. And this would be 1, 5, 6. I was about to say this wouldn't work because I thought this was going to be... No, 1, 5, 6 won't work. That's beautiful. Right, so what I postulated here was that this was 2, 3, 4. And therefore adding up to 9. This adds up to 12. We've just worked that out. 21 there leaves 24 here. This would be 987. With 2, 3, 4 here, this would be 156. But this cage is either 9, 6 or 1, 4. So this can't be 156. So that is not the way this works out. This is not 2, 3, 4. And we now know that red is high. This is 6, 7, 8. This digit is 9. This one has to be 6 to add up to 15. I just want to check. I just want to check that I did this right. If that was 2, 3, 4, this would be 1, 4. Yeah, that would be 987 and 1 would clash. I did do it right. It's fine. It's fine. Oh, what's going on? I don't know. This wasn't 2, 3, 4. It's 8, 7, 6. This is a 9. This is a 6. That's a 15 cage. This Renban works. These are high as well now because we know red's high. This pair is a 1, 2 pair. They're low. Now, this adds up to 12 and it doesn't involve 9, 8, 7 or 6. So this is 5, 4, 3 to get there. This is 1, 2, 9 which adds up to 12 and is divisible by 3. And in the rest of this row, now this is where I worry that I can't find a pair from 1, 2, 7, 8 that's going to be divisible by 5, but 2, 8 does it. Doesn't everything else fail? 8 with 2 does it. 8 with 1 doesn't. 7 with 2 or 1 doesn't. 8, 7 does it, but 1, 2 doesn't. So this is either 8, 7 or 8, 2. It's got an 8 in and no 1. Now there's an 8 there, there's an 8 here. There's got to be an 8 in this cage. It doesn't go with a 2 to make a sum of 10, so it goes with a 7 to make a sum of 15. This is now not 6 or 7. These digits are from 3, 4, 5. These digits are from 3, 4, 5, 6, and that's quite challenging. These two have to be the same polarity. They have to both be either high or low, or they can't both be high, and they can't be 5. So that's a 3, 4 pair. And this digit, which touches them both, has to be 9. This one can't be 4, because it's got to touch that digit as well. So we can fill in the whole of this line. And that, oh no, this one is not 4 or 3. That's a 5. This is 6. I haven't decided what this is yet. That's now a 4, 3 pair. This might get us there. 6, 7, 8, 4, 3. These are from 1, 2, 5, 9. Now, we know that the blue digits can't be 5. In fact, the 5 in this row is determined as being in one of these. In fact, I can now colour all of these pink. No, lots of these not pink, but blue, because they can't be a 5. So now there must be a 5 in one of those cells in box 3. No 5 in those cells. There must be a 5 in one of those two in box 1. 3, 4, 5, 9, 6. This is not 8. It's 1, 2, or 7. Wow, I mean, this was progress. These can't have 5 or 7 in. That's a 3, 4, 6 triple. Now, this green line is interesting, even though it's little. 9, 8, 3, 4, 6 are unavailable for this line. The only high digit available is a 7, and that must go with 1 or 2. Should I think about this cage? I don't know. Divisible by 3 is not that powerful yet. This can't be a 5 on a green line. That is low. This must be high. This must be low. This is high, but it's not allowed to be 8. In this position, it can't be 6 because both of its neighbours would have to be 1. So that's 7 or 9. This is 1, 2, or 3. This is 7, 8, 9. I'm ruling out 6 by Sudoku from that one. Look, there's a weird 7, 8, 9 triple in the row. I think I could get rid of all the blue and pink colouring because that's very much done its job at this point. Oh, there we go. And we're kind of making progress on the puzzle as a whole rather than just on the break-in by this point. I'm annoyed I don't know whether this is 8-2 or 8-7, but I don't. These have not contributed many candidates, many cells to their box. I don't know what to do next. How about this pair? Can't use 3, 4, 6, 7 or 5. So these are selected from 1, 2, 8 or 9. Well, they've got to add up to 10. They can't be both high or both low. They're not divisible by 5. So it's a pair that adds up to 10. We can't have 9, 1 that way around because of this digit. So we're using the other digit from 1, 2 that the green line isn't using. And these cells are being selected from 5, 8, 9. Now, have we narrowed the candidates here enough? I don't think so. I'm not even going to try the various cases here because it just looks too flimsy in terms of evidence to work on. Right, I'm going to look at this 5 cage. We've had 24 taken out of this cage in 987, this box with 987. Now, this is divisible by 5. It's not going to, it could add up to 10. It could be 1, 2, 3, 4 with a 5, 6 here. If it added up to 20, 6, 5, 4, 3 are the next highest digits available. They only add up to 18, so it can't add up to 20. So this either adds up to 10, leaving this to be a 5, 6 pair, or it adds up to 15, leaving these to add up to 6. But they could be 5, 1 in either order or 4, 2 in either order. So that's not actually all that powerful. Bother, it's doing well. This pair adds up to something divisible by 10. No, by 5. Sorry, not by 10, by 5. Doesn't use 9, 8 or 5. What about, I can't do this yet. This group? I don't know now. I don't know where I can find information. The Ren bands are all exhausted as possible sources. Okay, I've got to think again somehow. This is annoying. I want information. I'm not getting it. Oh, 9 and I was going to say 9 and 8 in this column must both be in this cage. That would have been incredibly useful if it was true, but it might not be because that digit can be 9. 8. Oh, 8 is placed in this box. I hadn't seen that. Now 8 is definitely in this cage. That's how I spotted that, in fact. So 8 is in this cage. That's not enough info. It just isn't. Ow, how do we get progress here? That includes one of 9 or 8, and that includes the other one. So only one of them will be in this cage based on where else they appear in rows 1, 2, 3. I mean, that's not very interesting. I don't know what to do next. Has this line become more fixed than I realised somehow? Have I mispencil marked it for instance? I kept wanting to say for interest there. Okay, I'm going to have to think about this 3 cage. If that was a 5, we would have 5, 12, and then, I don't know, this is so variable. I don't know. That's not going to do anything. No, there's no point wasting time thinking about nonsense. If that was 1, 2, 3, 4, would we have a problem? You'd have 5 and 6 here. I can't see the problem. There might be one, but I can't see it. That is 2. If that was 2, we've got 1 here and 7 here. If it was 7. Oh, there can't be a 5 in this cage, because we know 5's in one of those cells. So let's think about this cage, which can't have a 6 or a 5 in it. It can't be 987. If it has 2 of those big digits from 987, which it would do if that's not a 9, it would have 9 and 8. Then it would also have to have, I think, 3 to get to 20. Yeah. So 983 is one possibility here, in which case that would be 7. That would be 1 or 2. That would also be 1 or 2. If this was 7, this would have to be a 1-2 pair. Is that doing anything? It can't be. It can't be. I don't get it. I don't get it. 9, 8, there's a 7 here. There's a 7. I don't know. Is it really this cage? I can't be doing with thinking about that. There's so many possibilities. Oh, there we go. So I will come back to this. Probably not a bad moment to break, but I'll see you again in a bit. Okay, I'm back. And now, what were we looking at? We were looking at this. And we know there's an 8 in it by Sudoku. I was wondering whether another high digit could go in. So I'm going to think about those numbers. If 9 was in this with 8, it can't be 987 because that would break that cell and add up to 24. That's nonsense. So 9 and 8 would be 17 plus 3 would get to a number divisible by 5. You couldn't add 8. So 983 is what would happen if 9 was in this with 8. If 7 was in this with 8, 8, 7, 5. And you can't have 5 in there because 5's in one of these cells. So it can't be just 8 and... In fact, does that now mean 7 can't be in here? Because it can't be in here with 9. And it can't be in here with 8 and not 9. Right. That is not a 7. 7 is not in this. It's either 983 or it's 8 and 2 digits which aren't from 9, 8, 7, 6 or 5. 843 would work. Would be 15. That's divisible by 5. Oh, 821 doesn't get down to the next number that's divisible by 5. It only gets down to 11. So it would have to be 843. I think I've just proved, correct me if I'm wrong, that this is either 983 or 843, and 3 is in it, and we're only selecting from 4, 3, 8, and 9 in the cage. It's a shame 9 doesn't have to be in it, because that would make this a 7, and this would be a 1-2 pair. Now, if 9's in the cage, oh, this is never 3, because 3's either in the cage, and this can't be 3, or 9's in the cage, and that digit's a 7, which can't be next to 3 on the line. So that is now 1 or 2. Okay, let's think about the column. We know that 8 and 3 have been used there. If it's 983, that's not a 9. If it's 983, that's a 7, and that's placing 7 there in box 4. That's interesting. That's not a 9, by the way. I've just noticed that. I wish I could say 9 was... No, I don't care about where 9 is. 9's in one of those cells and one of these. Okay, forget that. Okay, let's go back to 983. That would be 7. That would be 6. These would be from 1, 2, 4, 5. If this is 8, 4, 3, that's 6. These are from 1, 2, 7, 5. So we're either selecting from 1, 2, 4, 5 or 1, 2, 7, 5 up here. That feels like weird combinations. That one can't be a 7 by Sudoku. I don't think it's helping enough for this cage, annoyingly. Oh, that's an 8, 9 pair, and this digit is 7. Sorry if you were shouting that. I have not been using this 7, 8, 9 triple that I saw ages ago. I don't know, it's very difficult to use it though. None of these could have been 7, 8, 9 anyway. Oh, well no, hang on. We know 7's in this cage now that 7 is there. If this was a 9 and 7 was in the cage, I mean, the trouble is a 3 divisor cage is just not interesting. There are so many possibilities. I'm just thinking, okay, if 9 and 7 were in this cage, this would be 8, 4, 3. They would add up to 16. We'd have 1, 2, 5, 6 left to make up the balance. 16 would go up to 21 wouldn't work. It would be 24, I think. I don't know, that's too difficult to work on in my head. Am I being pusillanimous, not daring to grapple with that? Maybe. I don't have the guts. I don't have the guts to try and work out all the combos if 7 is either in this cage. Well, 7 is definitely in this cage. Sorry, if 9 is in this cage or if it's not in this cage. So let's think again, just about this being 983, which is perfectly good. That adds up to 20. 983. Oh, I was going to say we'd also have a 789 triple, but that's not known because this could be 3. 983 there, though, would give that as a 6. Oh, this would become a 7. That's how this works, isn't it? Nine, 8, 3, 7. That would be 2. Ah, that would be 2. This would be 7, and that would have to be 1. So if this is 983, this is 716. These are definitely 2, 4, 5 at that point. Oh, hang on. What's this? This is made up from 1, 3, 6, and 7. I think that would have to be a 7-3 pair. I mean, that's quite in... Okay, that doesn't work. That doesn't work because this digit can't be 3 or 7. Okay, this is complicated, but I'm going to use it because I don't... Before the break, I couldn't see anything, and after the break, I haven't come up with anything else. But if this was 983, look, you'd get a 7 here, 2 here. That digit would have to be a 1, and that's where 7 would go in the box. So these would be 2, 4, 5. Now I've only got 1, 3, 6, 7 for these cells, and I've got to make up a divisible by 5 cage that can't sum to 5 and can't get to 15. It must sum to 10. It must be a 3, 7 pair, but that's impossible because we've got 3 there and 7 here. So this is not 983. This is 843, and this digit has to be 8 because it's high, and these ones are a 3, 4 pair. That's now a 9, which does nothing there, but 8, 3, 4 here, we can take 4 out of those cells. Now, what else is happening? I don't know, this doesn't do so much in the box, I know that, but the 9 in the column has to be here. 9 is in the cage, Now 7 is also in the cage now. Now I am going to think about how we accommodate both of those, especially as we now know 8, 3, 4 are not in it. So we're making up this cage with 9 and 7, and now I am going to do the thing I was being pusillanimous about earlier. Good word. Anyway, 9 and 7 are 16, plus digits from 1, 2, 5, 6 to get to a number divisible by 3. It can't be 18. 21 would require 2 of 1, 2, 5, 6 to add up to 5, which they do not do. 24 would require them to add up to 8, which would have to be 6 and 2. 6 and 5 will work as well. Oh, no. 6 and 5 won't work because that digit in the cage is 1 or 2. So this is 9762, this cage, which adds up to 24. I really think I've proved that, but wow. I mean, it's hanging on the flimsy bit of maths that I can keep. I mean, I'm right at the limit of the amount of maths I can juggle in my head there, but I think I've proved that. This is a 1-5 pair. That 2 is ruling out a 2 from here. Now I've got a 1-5 pair in the column. That can't be 9 in this column. I've got 3, 6, and 7 to accommodate in the column. There's a 4 in one of these cells. Can it be there? Yes, with a 6. Bother. Oh, goodness, come on. 9, 7, 6 there. I've got this 1-5 pair. Everything in this row is 2, 3, 4, or 6. That cell can't be 6. This is not going to fly, is it, to determine what's in this divisible by 5 cage. That's really annoying because I thought we were getting something good done there. I'm going to take the corner marks out. This is a 6, 7, 9 triple. That's fine. Okay, let's go back to this row. One of those 2 is a 3. Okay, this column, there might be some sort of quad going on here. I can't see it. 9's down. I don't know. Oh, botheration. I thought I might be on the verge of cracking through everything there. Okay, that didn't happen. All right, let's think about... Can I think about that cage? No, I don't think so. That is 1, 2, or 7. I wish I knew more about that. 1, 2, 5 triple, that 1 or 2. This colouring's not doing anything anymore, is it? Let's get rid of it. This could still be a 7. If that was a 7, this would have to be a 1. Now, other things would happen. This would be 6. This would be 9. That would be 8. 7 and 6 with a 9 there. 7 there would force this to be a 2 and put 7 there again. These would be from 1, 2, 5. I'm still not thinking about this cage. Actually, the fact that that can repeat a digit is possibly what's scaring me off bothering to think about this cage. Bother. Okay, let's look at this again. We know it's got 1 of 9 or 8 in it. Oh, I just do not know what to do with that. This 3 or 4 must go into this cage. It could still be 1, 2, 3, 4. If that was 5, 6, we would have 7, 9, 8. These digits would be from 1, 2, 3, 4. That doesn't work because too many cells here would be from 1, 2, 3, 4, 6. You couldn't force 5, 7, and 8 into those cells. Okay. So this can't add up to 10. And it's not big enough. It can't add up to 20, so it definitely adds up to 15. With the 24 there, this pair adds up to 6. It's either 1, 5 or 2, 4. If it was 2, 4, that would be 3, that would be 6. This would be a 1, 5 pair. That would stop this being 1, and that would stop this being 7. This already can't be 2. So if that was a 1, 5 pair, this would be a 3, 4 pair. 1, 5, 3, 4, 2. The 9 in the row? I don't know. I don't know quite what that does. I think it does something, but I don't know what it does. Dash. Come on, that 9, 9, 8 here. I feel like I'm on the verge of one more deduction, surely at this point. 5 is definitely in one of those cells. Okay, if 5 was there, this would add up to 22. Plus these 2 would take it to, could even be 24 at that point with a pair of 1s. Yeah, I don't know. That is not worth troubling myself over at the moment. Oh, okay. If that wasn't 2, 4, if that was 1, 5. Ah, hang on. If that was 2, 4, that's 4. This would become 3 with the 1, 5 there. That 3 is going to require that to be 9 and that to be 8. 2, 4, 9, 8. Oh, do we have this problem? If that's 1, 5, 1 and 5 have to go in these cells in row 8. Is that a problem? This is getting forced potentially quite high. No, I cannot see it. And now I'm going to have to take another break. Oh, bother. Oh, just on the verge of getting my head around this. Oh, I'll be back in a second. Sorry. Right, well, annoying to be interrupted again, especially at a point at which I didn't have a clue what to do. So maybe the break will do some good and I'll be looking at some part of the puzzle I wasn't looking at before and getting bogged down in. This 5 cage. We've only recently filled in these possibilities. So it could add up to 5 if it was 3, 2. It can't be 15 because that being 6 or 7 would need an 8 or a 9 here, which is impossible. But this could be a 3, 7 cage either way round, or 6, 4 to be 10, or 3, 2. So this digit can be anything from 2 to complete 5, 4 to complete 6, 4, or 3 or 7. If it's not 4, that's a 4. Does this 2? No, it can't be 3 by Sudoku. Does that mean this can't be 7? That might be worth knowing. Yes, it does. So it's either 3, 2 or 3, 7 or 6, 4. Ooh, if it was 6, 4, that would definitely be 3. So 3 has to now be there or there in the row. Doesn't feel very exciting. 6, 4, 3, 7 or 3, 2 now. What else is going on in the columns? Right, that was 6 or 7. One of these has to be 3. I'd forgotten that. I just don't think this cage is worth doing all the possibilities for because of the 3 multiple and the fact that it just doesn't seem to be any good. This one has a 9 or an 8 in. I have said that, I know, a repeated number of times. Oh, hang on. If this was 7, that digit is 7. That doesn't help. If it was 2, that's a 1, 5 pair, and that's 7. Oh, goodness. Have I just missed some cage? This one, I haven't really focused on that or that, and they're both 3 multiples. I don't know. There's just so much variability. I can't be doing with it. This one adds up to 20, I remember no, to 15, wasn't it? And that pair adds up to 6. If that's a 2-4 pair, that's a 2-4 pair, and this has to be a 2-4 pair. Okay, if this is a 2-4 pair, this is the 6 and this is 3. So then we've got 3 there and 4 specifically there. So if it's the 2-4 pair, 4 would have to be this side. So this can't be 2 and that can't be 4. 4 would be there and there. 2 would be here. And therefore at the top, 2 would be in one of those cells. That's not any use. Oh, there's something about modularity in general that I'm just not picking up on. That's what I think. 1, 2, 5, 6, 7, 9, 3, 8. There's a 4 up there. If that was 7, this would be a 9-6 pair. No, if this was 6, that would force more things. That would force that to be a 3, and this would be a 9-7 pair. And then this couldn't be 7 and would have to be 2, and that would have no fill. Right, where did that start? If this was 6, I think it broke down. That would be 3. This 7-9 pair would force that to be 2, and this would have no fill. So this can't be 6. That'll do. 7 there. 9 here, which is no good for the whisper, but never mind. 9 and 6. Now, this is not 7. So this is a definite 3-6 pair. This has not been resolved by that. 7 and 9 here. It does sort out 8 and 9 over this side. 8 there is going to put 8 into one of these 2 cells. Could be in the 4 cage, which I have not really thought very hard about at all. 2-6 there. And, is this going to be impossible one way round? 1-5 seems to work. Then this would be 3-4, and this would be an 8-7 pair. In fact, this is an 8-7 pair. That's just given now. And these are from 1, 3, 4, 5, and I don't think that is going to allow me to know what this is. If that was 4-2, that's 4-2, and that's 4-2. The whisper has done nothing. It's not evolved at all. That's so frustrating. That 3-6 pair doesn't do much either, I don't think. Oh, goodness, you make a breakthrough. You hope it's going to give you a big step forward. And no. That being, if that was a 4, this would be a 4-3-6 triple. And 5's there. So you'd be making up this cage from 1, 2, 7, 8, 9. Now they add up to 27. You'd have to take out, you couldn't take out a pair adding up to 7. There isn't a pair adding up to 12 in 9, 8, 7, 2, 1. No. There is a pair adding up to 17. That's 9 and 8, but that would leave this being 1, 2, 7. That is extraordinary, right? This doesn't work with a 4 here. So let me explain that again. If this was a 4, that would be a 3-6 pair in the row. We know there's a 5 there. So the only digits we'd have available here would be 1, 2, 7, 8, 9. They add up to 27. You'd have to remove digits that either added up to 2, impossible, 7, you can't do that with 1, 2, 7, 8, 9, 12 or 17. 12, there is not a pair within 9, 8, 7, 2, 1 that adds up to 12, and 17, there is a pair, but it's 9, 8. And if you took them out, that would be 1, 2, 7 and would break that cell. So this is not the 4. This is the 4. Wow, that is a good deduction. That goes with a 6 here to make that cage work. This is a 3. This is a 3 in the corner. That's 3 in the corner. I feel like celebrating that now. Right, now, this digit, it's not 5, so it's 1, 2, or 7. This is where it's all going to go, well, you know, you got something, but it doesn't actually help solve the puzzle. Okay, this cage is going to use an 8 or a 9 and a 4 or a 6. And then a 1, 2, or 7. And it's going to be divisible by 5. If it was 9, 8, it's impossible. No, it's not 9, 8. It's using 1 from 9, 8 and 1 from 6, 4. So if it was 9, 6, it would need the 5. That's not what's happening. If it was 8, 6, it would need a 6 or a 1. It would be 8, 6, 1. That's possible, annoyingly. If it was 9, 4, it would need a 2 or a 7. That's depressing, because they're all the possibilities now. And I mean, I still haven't even considered 8, 4. Well, I don't have to consider that because it's not possible, but... So 8, 4 is not possible, and 9, 6 is not possible. That's really irritating. Okay, no, that's okay. No, it's not. I was going to think that told me what this pair was, which would tell me something about this cage, which is divisible by 3. Oh, I can't work that out. Oh, back to the drawing board. Surely not. Surely not all the way back to the drawing board. Must have done something. Just looking down at the bottom of the puzzle, not really seeing where to go for eggs down there. Oh. Rats. Okay, I'm going to have to think about this. So, it's either a 9, 4 pair here, going with 2 or 7, or it's an 8, 6, 1 group. Maybe we could disprove 8, 6, 1. Then this would be a 4. This would be a 5, 9 pair. That would be a 6. In this cage, we'd have 6 and 7 is 13. You could have 2 and 5. You couldn't have 6, 7, 1. And, oh no, this is not divisible by 5. This is divisible by 3, so start again. 6, 7, and 2, and 9 would work. 6, 7, 1... wouldn't work. Oh, that's quite interesting. 6, 7, 2, 9. Yeah, that's divisible by 3. 6, 7, 1, 19, 22, or 23. No, they're no good. If that's a 6, this is a 9. Then that's 2, 8. This would have to be 4, 5. And that's no good. That would put... oh no, that would put 8, 6 in here with a 1. That's okay. Ah, that's annoying. So that was quite interesting though, that 6 only gave one possibility there. I've better try it for 4. 4, 7, 1, that's already divisible by 3. That would use the 9 again. 4, 2, 1 is 7. Well, this could be 5 or 8 then. No, it can't be 4, 2, 1. This is a whisper. 4, 7. What am I doing? 4, 7, 1. I worked that out. That goes with a 9. 4, 7, 2. That's the other possibility. That's 13. 4, 7, 2 is 13. Oh, plus 5 or 8 does work. No, but if this is 472, that's a 1-9. Yeah, that's exactly what does work. The 1-9 pair up there. Oh, I didn't get there with that. Wow. I mean, one way round this must work, and the other way it doesn't. I'm really sorry. I'm up here. I'm really going to have to just focus on how to do it. I mean, it's those cases that are going to resolve this. And it is just modular mayhem. So let's try it again. If that's a 6, this is a 9, and that's a 4, and that's 2, 8, and this is 5. We'd have 9, 5, 4 here. So then this has to be 8, 6, 1. And that's a 2, 7 pair in that case. This is not, okay, let's just think about what's gone on here. If that's 6 and that's 9, that's 2, 8. This is 4, 5. This is 7, 1. So we've had 6, 7, 1. Oh, do you know what? I should be just thinking about this takes out one of the pairs that sums to 10. If that takes out 1, 9, then down here we've got 7, 2, either 5 or 8, which are the same as regards modularity, and 3. And that has to be 6. So if that's 1, 9, that's a 6. If that's 2, 8, this is now 1, 7. But that's 5 or 9, and that's 4 or 6, and I don't quite know. I don't think this could ever be 5, actually. If that's 1, 7, with a 5 here would be on 13. That would give 17 or 19. That couldn't be 5. Oh, does that mean this can never be 5? That would actually be worth learning. Right, let's go through that again. If this is a 1, 9 pair, that's 2, 7. And these are going to be 6 and 9. Oh, they could be 5 and 4. 1, 9, 2, 7. They couldn't be 6 and 9 because we're postulating 1, 9 at the top. So they would have to be 5 and 4. So 5 would be in this cage. So if that's 1, 9, oh no, they could be 8 and 4 as well. I think I've worked this out before. I just can't keep it in my head. If that was 1, 9, this can be 5, 4 or 8, 4. If that's 2, 8, these are 1, 7. I just can't keep this straight. That couldn't be 6. That would have to be 4. Oh, maybe this is always 4. I mean, that would be worth learning too. Right. Let's see how this could be 6. With 7, 2 here, that would be 9. But 2 and 9 would both have been used, and that would be broken. 6 with 7, 1 here, that adds up to 14. It can never get there. This can never be 6. Oh, goodness. I mean, I think I was on the verge of discovering that ages ago. Now, 4 now has to be in this cage, and 6 isn't. Now I think I know which of 9 or 8 goes in this. If 8 was in here, oh, hang on. I can't remember which way around it was. Right, if 8 was in here, we're up to 12, but we can't add 3 or 8 to get it to 15 or 20. So 8 can't go in here. So the big digit that goes in here is 9. And that does not go in these cells now. So 4, 9 goes in here, either with 2 or 7. And the other one of those, so one of these two is a 1. And these cells can't be 1s now. 8 is in that group. So this is a 1, 9 pair in this box. That's a 2-7 pair. And we will find that this cage is divisible by 3, whether that's 5 or 8. Yes, okay, that is true. Okay, still, progress has occurred. These are from 2, 5, 7, 8. This seems to be, oh look, 2, 7 there is looking at that cell and making it a 5. And now these are 1, 3, 6, which are a very constrained set. Now, this adds up to 22 plus these 2 cells, and it's divisible by 3, so they could both be 1s. That's the only way they could contain a repeat digit. Or this could be 7 and this could be 1. If this was 3 or 6, that would be 25 or 28. This would be a 2. I don't know. Still a very difficult cage to work out, although it's the last mattering cage. No, this is probably the last mattering cage. Okay, have we got anything more done? We've got that 1, 5 pair in this column. In these 2 columns, maybe something has occurred. 1 there is ruled out of those cells. 6 is placed in this box now, apparently. It's there. This is adding up to 6, so that can't be a 5 anymore. So now 5 is in one of these 2 cells where it's always been. That 6 gets ruled out of those 2. Has that created some sort of marvelous quintuple up one of these columns? Oh, it's so complicated still. That can't be 9. This cage is done. It doesn't matter whether that's 5 or 8, it works. That whisper is done. This cage is very much not done. 22, and then these 2 add up to 2, 5, 8, or 11. Well, they don't add up to 11. There's no combo that works. So they add up to 2, 5, or 8. A pair of 1s, a 2 and then a 3. A 2 and a 6, or a 7 and a 1. I can't rule any digit out or in. I'm going to have to think about this beastie. What can this be? Can't be 7, 9, or 8. Is that really all? Okay, imagine this was from 2, 3, or 4. So they would be a set here. 2, 3, 4, 9 would all be missing from the cage. And they add up to 18. We could take out a 7 there. And this would add up to 20 as the remainder of the box. So that could be 2, 3, or 4, and this would be 7. If it wasn't 2, 3, or 4, it would have to be 1, 5, or 6. Now 1 and 5 are in the same modular group as respects 4. I don't know what that would mean. I can't work it out at all. Two, 3, 4 was the only useful thing. Well, oh no, hang on. If this was from any of the low digits, 1, 2, 3, or 4, this is a 5, 6 pair that would have to be in this cage. They would add up to 11. With 7 there, you couldn't do this. But with 8 there, this would be 1. 5, 6, 8, 1. So if this is low, this goes 1, 8 here. And it would have to. If this is not low though, if it's 5 or 6, what then? does something occur that I cannot rationalize? Well, 5 will be in this cage along with 1. So they'll add up to 6. Then there's another low digit and 7 or 8. 7, 3 would get us to 16. Or 8, 2. It can't be 8, 2 because that's not 5, 6, 8 or 2. What was I saying? I don't even know. If this was 5 or 6, did I choose one of them? I probably did. Yeah, but I don't know what I just did. Oh, I can't even remember. It was so complicated, but it probably needs to be done. Or this cage, how am I going to sort this out? If they were a pair of 1s, everything's fine. If they were 2 and 3, this would be 4, 7, 9. That would be 1. I can't work out where this has a weak spot at the moment. It's not on the whisper. We've done the whispers and the wren bands. We've basically done the cages with this one still to go. And this one. But we've done all the other cages, including this one, as long as we make these add up to 6. Now, okay, maybe that's a point. Maybe that is an actual point. Yeah, say this is 4, 2. That digit is a 3. These are then from 1, 5, 6. And that's 3 or 4. I just think that gives enough variability that I don't know what's happening. Or maybe I do. Right, if that's 4, 2, these are from 1, 5, 6. And that is not 1, that is 3 or 4. Now, 5, 6 won't work here, I think, because 7 would need a 2. 11, oh no, 5, 6, 8, 1. No, and that couldn't be a 1 by what I've just worked out with that. So 5, 6 wouldn't work here. This is if this is 4, 2. 5, 1, they would add up to 6. That being an 8 would again require this to be a 2. That being a 7 would allow this to be a 3. Oh, bother. 5, 1, 7, 3. Oh, if they were 4, 2, this would be a 4. So that isn't even able to be a 4 or a 1. That would have to be a 3. If they're 4, 2, that's always a 3. Right, so 5, 1, 3, 7 works. 6, 1 probably doesn't. 6, 1, 3 is 10. Yeah, you can't use 8 or 7 then. So if that's 4, 2, this has to be 5, 1, 3, 7. Is there something that goes wrong up these columns? No, I don't think so. That was all based on this being 4, 2, which seemed to be the most interesting circumstance. Oh no, look! Where's 5 in this box, you numpty Mark? You've marked it all up. 5 has to be in one of those cells. There we go. Okay, well, I'm not a numpty. I've figured it out. That's a 4, 2 pair. This is going to do the job because I've just worked out everything else. Actually, I can just fill in these columns straight away. Incredible, incredible. That was doable. I can't deny it. Right. That's now not a 1 because of this 5-1 pair. 2-4 there fixes another 3 in the corner. That's 3 in the corner. Let's relish the things we can find. This is a 1-5-6 triple. And now I have worked out this can't be 5-6. Because with the 3 there, we don't get a multiple of 4. So 1 has to be in the cage. So 1 and 3 are in the cage. That's 4. If we tried to do it with a 6, we don't get there. So we need the 5. So that's a 1-5 pair. This is a 6. And with the 1-5 pair, 9 there, that's a 7. And that's the only way to do it. Right. This is a 7 by Sudoku. This one is not 6. 7, oh, I don't know, but it's not in any of those cells now. Well, still not finished. I see that now. No, hang on. 8 can't be there. Something here. Come on. That can't be 3 and that can't be 3. 7, 9 there. Let's just look up this column. 2 places for 8. Things haven't entirely changed. This column, no. 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 Okay, but something somewhere has got easier now. I'm gonna track it down. I'm on your tail, puzzle. 6, 8, 7. 7 is, if that was a 7, that's 4 and that's 9. Then that's 9. This is an X-wing on 9s, definitely, already. Okay, let's look at this cell. 2 or 4 there. These are all from 1, 2, 3, 4, 5. 6 is X-winged between those. Oh, this has changed a bit because 3 came out of this cage. That really didn't change it much because 6 is still in and had the same modular value as 3. So they could still be both 1s, and they probably are given that rule. So that's 22. If that was a 2, this is a 6. And then that's 4, 7, 9. How is this actually going to have only one solution from this point? It seems very confusing that that would be the case, especially when this is the last cage to really need resolving, and it seems to have multiple ways of resolving. That's the big issue here. One of these is 7, the other one is 1 or 2. Whatever digit that is goes here, does it? Yeah, I think that's right. I don't think that helps anything. Okay, let's think about these two again then. If that's a 6, that is 2. If that's a 1, this is 1 or 7. So maybe the 6 and 2 version doesn't work. Why? Six there, 2 there forces 7, 1. This would be a 2. I don't see. Okay, stop being an idiot and just work it out. If that's a 6, that's a 2. And this is 7, 4, 9. And that's a 1, 3 pair. With 2, 5, 8 up here. But that being a 6 makes that a 6, makes that an 8, makes that an 8. don't know. What if this is an 8, which it probably isn't? That would be 8, that would be 6, this would be 1. We would then know this would also be 6, that's not a problem. If this was 1, that would be 3. Oh, then we'd have 4, 2, 4. So we'd have 4s in those positions. How can this possibly resolve uniquely? I just can't get it. If this was a 6, this would be a 2. Why is that any kind of a problem? Oh, if that's a 2, this is 7, this has to be 1. And then that's 5 and 2, and that's always 7. Yeah, I don't know, that's just not doing anything. I mean, I've done so much work here. I do not want to fall at the last hurdle. Oh, there's only one place to put 5 in this column. Look, that's a 1, 2, 3, 4, 9 quad, quintuple. So that's a 5. Weird. I mean, I don't think that's going to resolve anything, but let's look more carefully at this column now. Is there only one place to put 5 here? Yes. No, there are 2. And there's 2 there. So no, calm down. 1, 5, 2, 3, 4, 6, 8. Wow, something is happening here. For this to be a 7 makes that a 2. Ah, for this to be a 7 makes that a 2. Once this is 1 or 7, in this cage, that has to be 1. So for this to be a 7, that's a 1. If they were 7 and 1 together, 5, 4, 2, 9, 7 and 1. There's nowhere for 8 and 6 to go in the column. If those are 7 and 1, if that's a 7, this has to be 2. That is now 1 or 7, and according to this cage's modularity, that's a 1. And if those are 7 and 1, you can't get 8 and 6 into column 4. You can only get one of them into that cell. So that is not 7. Oh, that is complicated. So that's a 2-8 pair. This digit is 7. Now that takes 7 out of those cells and definitely puts 7 in here. I don't think it's going to do all that much else. Yes, it does. The 2-8 pair takes 2 out of these cells, and now they're definitely 4, 7, 9, and that we can actually fill them in. Look, that's 4, that's 9, that's 7. I mean, still haven't resolved this one. It's either a 1-1 pair or a 6-2 pair. That 4, though, is looking at this cell. That's not going to do anything, I don't feel. 9 can't be here, so we've placed 9. All the 9s, I imagine, are done now. So are we going to do the same thing again? Look, there's only 2 columns with 3 candidates in now. 2 cells, I mean, with 3 candidates in. This is madness. 7 and 9. So, again in this column. Or have we got a 2, 4, 6, 8 quad? No, we absolutely haven't. Okay, let's try up here. 5, I just can't believe this is still holding out. It's vicious. Right, if that was a 6-2 pair. Six there, 2 there. You've got 1 here and here. and here. What's wrong with that? You've got a 1-3 pair. Well, I mean, you could fill in this whole column with 6 there. That's 8. That's 2, 4, 5, 1. But why is there any difficulty with that? So 6 here. This is incredible that this is still unique and yet solvable. I almost can't believe it. Or I'm missing a very simple, only one place for something. Deduction, which is barely qualifies as a deduction if that's the case. Okay, if they were both 1s, then we're going to get a 1 in one of these positions, a 1 there, a 1 here. I just don't see we'd get 1 there and 1 there. I don't see why that's a problem. Do you know what? I think it is. Is that a problem? If these were both 1s, that's a 1, that's a 1. Now, what's happening to 3? No, this cell is becoming a 3. Yeah, there's too many 5s in column 4. Right. If these were both 1s, that's a 1 and that's a 1. Now, this digit is 3 and that one is 4. But once that one is 4, this is 5 and this is also 5, and that's impossible. So it turns out they're not both 1s. They are 6 and 2, and that cage now successfully adds up to 30, which is divisible by 3. And it was the only way it could work, and I am a bit gobsmacked by that. Absolutely mind-blowing. But that is going to let us finish. 6 there means we can do the whole of this column, 8, 2, 4, 5, 1, and obviously we can now finish the rest of the puzzle with some absolute quivering terror that it might not say it's correct, but it must be, because we've done everything. It's all been proved unique. Okay, I didn't actually take 3 hours to solve it, but I did take quite a long time. That is Modular Mayhem of the highest caliber. Extraordinary stuff. Thank you for sticking with me. My goodness, what a monster. I'm off for a long lie down now. I'll see you again tomorrow, hopefully. Have a great day, and bye for now.